Like any other management tool, MFCA requires a number of implementation steps. As outlined in this video is divided into two parts. The first part introduces the implementation steps of MFCA, and the second part explains practical cases. Outline of the MFCA implementation steps constructed in accordance with a PDCA site. The process of MFCA implementation is easier and faster in those that do so within the context of an existing EMS. The knowledge of potential environmental impacts and financial impacts can enhance the quality of the evaluation, providing useful information for decision-making. Step 1. Involvement of management. Management-level personnel should understand the value and practicability of MFCA in achieving an organization's environmental and financial goals. To be effectively implemented, MFCA should be strongly supported by management. Management involvement should include the following. Second, determination the necessary expertise. MFCA requires multiple types of expertise that can provide the diverse types of information needed for the analysis. The following examples summarize the types of expertise useful for implementation of MFCA. Step 3. Specification of a boundary and a time period. Before an MFCA analysis can be undertaken, the MFCA boundary should be specified. It is advisable to focus initially on a process or processes. Step 4. Determination of quantity centers. Various processes such as receiving, cleaning, cutting, mixing, assembling, heating, packing, inspecting and shipping, as well as material storage areas can be considered as quantity centers. The quantity centers within the MFCA boundary can be determined from process information, cost center records and other existing information. Step 5. For each quantity center within the MFCA boundary, the inputs and outputs should be identified. Possible inputs are materials and energy. Possible outputs are products, material losses, and energy losses. Step 6. Quantification of the material flows in physical units. For each quantity center, the amounts of inputs and outputs should be quantified in physical units. All physical units used should be convertible to a single standardized unit so that material balances can be conducted for each quantity center. A material balance requires that the total amount of outputs is equal to the total amount of inputs, taking into account any inventory changes within the quantity center. Now let's do a simple quiz. For each quantity center within the MFCA boundary, which item belongs to the input? A. Products. B. Material losses. C. Materials. And the correct answer is C. Step 7. Quantification of the material flows in monetary units. In the process of quantifying material flow in monetary units, there are four basic elements: material cost, energy cost, system cost, and waste management cost. The explanation of the four elements, where they come from, and how to quantify each element is presented next. The first is material cost. Material cost includes input and output material costs. For each quantity center, input and output material costs should be quantified. Material cost can be quantified in many different ways, such as historical cost, standard cost, replacement cost. The choice is at the discretion of the organization and may also be influenced by the methods the organization already uses in its existing cost accounting. Depending on the method chosen, the results of the MFCA analysis may vary. The image below is an example of calculating the cost of materials in a basic manufacturing process. This flowchart shows the boundaries of the material flow model within which the properties of each material remain constant throughout the process. For example, a part assembly operation, a batch mixing operation. In this example, two QCS are defined, each producing a separate product and material loss. After material costs have been calculated and assigned to products and material losses, the next step is to calculate energy costs, system costs, and waste management costs and assign these costs to product and material losses. Ideally, energy costs, system costs, and waste management costs should be calculated directly from the available production cost data for each QC. Energy cost comes from all energy used in the production process. For each quantified center, the cost of energy used should be quantified. If the energy costs of individual quantification centers are unknown and difficult to measure or estimate, it is necessary to assign the total energy cost of the selected process to the quantification centers. Subsequently, the energy costs for each quantity center should be allocated to product and material losses. System costs are all costs incurred in handling material flows internally, excluding material costs, energy costs, and waste management costs. Examples of system costs are labor, depreciation, maintenance, transportation. The system cost associated with each quantity center should be quantified. If the system cost of an individual quantity center is unknown and difficult to measure or estimate, it is necessary to assign the total system cost of the selected process to the quantity center. Subsequently, the system costs for each quantity center should be allocated to product and material losses. Waste management cost is related to the loss of material from the disposal quantity center. Waste management costs associated with each quantitative center should be quantified. If the waste management cost of an individual quantification center is unknown and difficult to measure or estimate, it is necessary to allocate the total waste management cost of the selected process to the quantification center. The total waste management cost for each quantification center should be attributed to the loss of material leaving that quantification center. Step 8: MFCA Data Summary and Interpretation. This step is to summarize the data obtained during the MFCA analysis in a format suitable for further interpretation. The table below is an example. The data in the table represent total material input plus inventory changes for inbound product and material loss, and costs associated with product and material loss, respectively. Step 9 and Step 10. Communication and improvement of MFCA results. Once the MFCA analysis is complete, the results should be communicated to the relevant stakeholders. Most MFCA stakeholders will be within the organization. Management can use MFCA information to support many different types of decisions aimed at improving environmental and financial performance. Once MFCA analysis helps organizations better understand the magnitude, consequences, and drivers of material use and loss, organizations may review MFCA data and pursue opportunities to improve environmental and financial performance. Finally, organizations can adopt new strategies to improve. Quiz. Material cost can be quantified by many different methods, and either way, the results of the MFCA analysis are the same. The correct answer is false. This case example shows actual implementation of material flow cost accounting in accordance with the implementation steps described in the previous section. Nitto Denko Corporation is a leading Japanese diversified materials manufacturer. It was the first model company that introduced material flow cost accounting with the support of the Japanese Ministry of Economy, Trade and Industry in the early 2000s. Step 1. Analyze current situation, establish management team and division of responsibilities. As a part of environmental management activities, Nitto found that its environmental accounting system was not fully representative of the total environmental impact costs of operations. Other costs, such as energy consumption cost associated with environmental impact, represents around 13.6% of total sales, which is significantly higher than the environmental conservation costs 1.6%. To make alternatives for its existing conventional environmental accounting, the team was established and guide MFCA implementation for target process. Step 2. Scope and boundary of the process and establishing a material flow model. As a first step, month-long data were collected for MFCA analysis. Then, the adhesive tape used in electronics produced was selected as the target product. due to the production lines generated a high amount of material losses, and consumed substantial amounts of energy in the manufacturing process. Thirdly, set up a quantity center based on loss analysis and process analysis for each production process. The team decided to divide the process into 5 quantity centers: dissolution or batch blending, coating or drying, store, slitting, and inspection or packing process. After the quantity centers were selected, NITO collected data for verification of the amount of inputs and outputs in physical units by doing a material balance. Step 3. Cost allocation. Costs were classified into 4 cost elements: material cost, energy cost, system cost, and waste disposal cost. To determine material costs, the physical amount of input materials in each quantity center was multiplied by their unit costs. Material cost flows were tracked through each quantity center. All collected costs are allocated to products and to material losses, following the material flow obtained through the material balance. In this process, NITO allocated energy costs and system costs based on the product or material loss ratio in physical units. Step 4. Interpreting and analysis MFCA results. After collecting all data in physical and monetary units, and making the material balance of the quantity center, prepared a material flow cost matrix, in which all costs were classified as part of the products or material losses. The main purpose of the matrix is to provide the results of the MFCA analysis in a format that can be easily interpreted by the entire organization. For the selected process, the proportion of positive products to negative products was 67.17% to 32.83%. MFCA provides information not only on the costs associated with the final product, but also with the material loss. Step 5. Improvement practice through MFCA result analysis. Through MFCA, the team set up its improvement plan on the basis of a cost or benefit analysis, using the physical and cost data under MFCA. The figure shows cost of negative products broken down by factor, and countermeasures were subsequently planned and implemented. NITO conducted an assessment of its capital investments, and decided on an additional 700 million capital investment. The proportion of positive products increased by 10%. There was, however, much room for improvement, and the company decided to introduce a continuous MFCA analysis in this process. After completing the project, NITO recognized the potential of this management tool. It provides a way to identify potential cost reductions and positive impacts on the environment. MFCA can help clarify losses in terms of cost, and grasps the cost of negative products for each quantity. It helps to determine the priority of process improvement, and enables managers to set clear targets for improvement. The improved performance will be made clear as saving from curtailing negative products. If you want to learn more information about material flow cost accounting, please refer to other group members' videos. Thank you for watching.